In this lesson, we are going to start to talk about a couple other techniques to finding some limits. So far, what we've had is some sort of a rational function. And the biggest thing that you're looking for, whether you need another technique, is whether that value is a domain issue on this. And so if that makes the denominator zero, we're going to need a different approach to this. Because in general, if you're going to find a limit, you're just plugging it in, seeing what y value you get. Remember, the limit is always about what the graph is approaching. Okay, so that only has a problem when your graph doesn't approach the same value from either side. And that really only happens when you have asymptotes and when you have piecewise functions. So, but when we come across it, we'll kind of talk through a couple different examples that you're going to be looking to factor, and then see if you can simplify some stuff with that, and go ahead and plug in. Or if you have a square root, you're going to want to be multiplying by a conjugate. So if you remember what a conjugate is, if you have a 3 plus the square root of 2, conjugate is 3 minus the square root of 2, or square root of x minus 5. The conjugate is going to be square root of x plus 5. So those are the other two kind of approaches. But you got to know when to use them. So we're going to talk about that. So again, just a quick refresher that the idea of the limit is that if we're finding the limit at a, that it's all about what you're approaching from either side. And on this example, you are approaching a whole, but you're approaching the same value from either side. So whether that value is something else or doesn't exist at all, that doesn't matter on the limit. Right? So the limit exists, but it does not actually equal the value. So this might be a 5 and this might be a 10, or you're approaching 5, but you never get there because the actual 5 does not exist. Okay, so let's do a couple examples and know how do we know that we can't just plug it in. So here's what we got. We have some sort of a rational. Rational are the ones that we're looking for that potentially have some problems. And we're looking for the limit as x approaches 2, right? So if you recall that this thing is going to factor, and it's going to factor into an x plus 2 and an x minus 2. So if you have an x plus 2 and an x minus 2, you have domain issues where your domain is x cannot equal 2 and negative 2. All right, and that just so happens that's one of the values that we're looking for. So if you were to plug in 2, you're like, all right, well, I'm just going to kind of plug in the value because that's what we do when we find the limit. That's great, but you're going to plug in and do 2 squared minus 6 times 2 plus 8. And you're going to be doing a 2 squared minus 4. And so we have a 4 minus 12 plus 8 over 4 minus 4. So if you put all the top together, you're going to get a 0. Denominator, you're going to get a 0. This, most of the time, is going to tell us that we have a whole. Okay, not for sure, but most likely that's what's about to happen. So a whole, whether the point exists or not, right, our limit is about to exist. So we need to figure out what that value is without being able to plug it in. So here's our approach. So we're going to kind of do some pre-calc to this. Is we graphed this type of thing. We were finding where asymptotes were. We were finding where holes were. We're going to do the same thing. So we're going to take our limit as x approaches 2 of this, but we're going to factor. We're going to factor the top. We're going to factor the bottom. Right? And so we need things that multiply to 8 that add up to negative 6. So we're looking at a 4 and a 2 and a negative on both of them. And then here, this is a difference of perfect squares. So x minus 2, x plus 2. All right, so the fact that we had a whole, this situation was almost a guarantee that this was about to happen, is that we had these two factors that could cancel each other, right? And in pre-calc, this represented that this was going to be a whole. So we're going to simplify that, cancel those common factors away. We are now left with x minus 4 over x plus 2. But now the problem's gone, because the problem was when we plugged in 2 into these, this is where your 0 came from, and this is where the other 0 came from. So 0 times whatever is 0. 0 times whatever was 0. So that was our problem causing our 0. Now we've kind of removed that problem. And if you plug in 2, we're okay. So now we're ready to just plug in. So we had to do a little bit of manipulation, a little bit of simplifying, cancel out the problem, basically. And then now we can plug in, get 2 minus 4 over 2 plus 2. which is going to get us a negative 2 over 4, which is negative 1/2. So if we were to graph this, we would see both sides of the equation would be approaching negative 1/2. Negative 1/2 can't happen because we can't plug into, because technically this whole thing is from the original and we have a domain issue at that spot. All right, so negative 1/2 is what we're approaching, which is exactly the idea of what a limit is. So our limit of this is negative 1/2. All right, so let's do the other situation. Is right here. So we have a domain issue again. And let's not even consider this domain issue because this is, we don't want to square root negatives. But let's just kind of look at the fact that our domain issue just exclusively from the bottom is x cannot equal 1 because it makes the denominator 0. Right? But, and that again, not coincidentally, that's the value that we're looking for the limit. So let's see if we have potential for a hole, and that hole is if we have that kind of a field to it. So if we plug this in, we have the square root of 1 minus 1 minus 1. So we're looking at a square root of 1 is 1 minus 1 is a 0 over 0. So again, potentially a hole. So let's see if we have another kind of common factor that's going to cancel out. So our approach with square roots is the conjugate. Right? So we're going to take x minus 1, square root of x minus 1. Sorry, our limit as x approaches 1, square root of 1 minus 1 over 1 minus 1. And we are going to multiply the top and the bottom by the numerators, wherever the square root is, that we're going to multiply that conjugate. Okay, so we're going to do some distribution on this. So our limit as x approaches 1. So we're going to do the square root of 1, or square root of x times the square root of x is going to be x. And then the square root of x times 1 is plus the square root of x. We're going to have a negative 1 times the square root of x is negative square root of x. And then a negative 1 times the negative or positive 1, it's going to be negative 1. Now, what I actually won't ever do is multiply the piece that's not the conjugate. If these two are conjugates of each other, those are the ones I'm going to distribute because some simplifying is going to work out. Don't do the other ones, and you'll see why. So we're going to leave these two alone. All right, and then we put our like terms together. These two are going to go away, and we're sitting with the limit as x approaches 1 of x minus 1 on the top, and then x minus 1 square root of x plus 1 on the bottom. So here's where the conjugate does. It's always going to simplify something out, get rid of whatever square roots it was, if it was on the numerator or the denominator. And here's our problem, right, of plugging 1 in. Here's our 0 over a 0. If that goes away, we're now sitting with the limit as x approaches 1 of 1 over the square root of x plus 1. Awesome. Now it's okay. So now we can go ahead and plug in. So we have a 1 over the square root of 1 plus 1. And that gives us 1 plus a 1 is a positive 1/2. Right? So that value is, again, if we were to graph this, and we were looking at the value from either side is approaching 1, we would be approaching a y value of 1/2. It would never get there because 1 is the problem, is a domain issue. We really couldn't be plugging in 1 to ever get the 1/2, but we would be approaching 1, and that's the idea. All right, and then we'll do one more example. We'll do this in a different video that has a little bit of a different feel, and we'll do lefts and rights and things like that. But those are your basic ideas, is that if you have a rational and that value is a domain issue, there's a pretty good chance that we're going to have a hole, but not always. There will be some other situations that it is an asymptote, so how do we deal with that? But this one ended up being a hole because the factors ended up canceling, and then we were able to plug it in. And then here with square roots, we're always going to want to approach, again, it's not a guarantee it's a hole, but we're going to approach it as we're going to multiply out the conjugate and then simplify it, and then it's going to remove the problem, and we can go ahead and plug it. All right, we'll do some more in the next video.